somebody mind grabbing this box for us? We're going to need the box.
Yeah, see that box there? Yeah.
One down, two to go, two to go.
I'll show you the whole thing. This is your reward for being so patient.
Pull forward. And you can take pictures of this, no problem. Take as many as you want. Smile, though.
We're disconnected.
Yeah, we're disconnected.
So this car is geared to go 150, and we got 150 in the runway recently. And it's geared to go 150 at the end of a straightaway on a racetrack. It's not. It could go faster, obviously, but at the end of a straightaway, like in Laguna Seca, it's geared to go about 150, and it goes 0 to. With this current gearing we have, it's kind of slow. It goes 0 to 100 in about 8 seconds. That's slow. On a racetrack, you only care about 40 to 150. 0 is not on a racetrack. You don't care about 0. So people ask us about 0, and we say we don't deal with 0. We deal with 40 to 150.
Please don't touch things because it's floating at over 400 volts. Yeah, 400 volts.
Do you want to kind of just run through the technology?
Yes, sure. Okay, so remember I was talking about an energy storage system. Okay, so here it is in reality. What we do is we build our systems in modules because modules give us this flexibility and give us, the scalability. So we've built these energy storage system boxes, which are here. There's 4 of them. 26 cells per box. These little boards are our own creations. We developed that here. And the little black tabs on there, they're plastic tabs because, to prevent any electrocution when you open it up. It's just an added little feature thing. What else is important to say? Okay, so yeah, the BMS we developed ourselves. The way we interconnect the little cells, we developed that ourselves and actually are patenting that. What we also patent is this enclosure. This is something we call carbon fiber reinforced polycarbonate. You can see that better on the go-kart. It's the same structure. We actually patent that. What we do is we started with polycarbonate. When you build battery boxes, there's a couple of things you got to start thinking about. It has to be insulating, has to be impact resistant, has to be stiff, and all these other things. So you can, you got these functional requirements. So you can satisfy each functional requirement with a material, or you can start to look at materials that satisfy 3 functional requirements, so that you can reduce weight, volume, and all those other things. That's what we did here. So polycarbonate is notorious for impact resistance. It's very insulating. It's very dielectric. So what we do is it's very also machinable. So we can machine polycarbonate, and in doing so, we can preserve the accuracy and precision of these enclosures, because they all need to be as equal as possible, because the cells are the same, and so on and so forth. So we build the box like that, and we use 3 methods of building the box, of actually heating sides to sides. We use a cement, which chemically disintegrates and melts the polycarbonate. Then we also mechanically, with bolts, screw them together. And on top of that, we wrap them in carbon fiber sheets. And that's what we actually patented, is this method, this process of developing carbon fiber reinforced polycarbonate. So these 4 modules are connected in series.
So why the last step?
The last step, the carbon is there for added impact resistance, because carbon is brilliant on the outside and it kind of has a soft core. So it's it behaves very flexibly, but very, very impact resistant. So if you get into a side impact, the carbon fiber will crack, and through doing that, it'll absorb most of the energy. And then the energy will spread through the polycarbonate and find its way on the back of the boxes. So what happens is the box absorbs the energy as opposed to repelling it. And that's the huge advantage of even composite bodies and unibodies and vehicles is you can absorb almost twice the energy that you can in steel, in stamped steel.